Hello friends, today in this particular video I will be talking about how to conduct t-test using SPSS. Now whenever we are talking about conducting t-test using SPSS or conducting t-test, you know that there are three basic type of t-test. One is independent sample t-test, the other one is paired sample t-test, and then one sample t-test is there. So I will try to make three different videos, one each at a time, depending upon the different types of t-test. So let us start. So you can see on this screen, in this is the one sample data set which is available in the SPSS sample files. This is about different types of aspects of particular group of people is there different because I already told you what are the different types of how to enter data in a SPSS file. So this is variable view, you can always see here. And so as you already know that this is the variable view, and here you can see that different variables are defined here, different variables and their type, then width, and these all things are there. So basically I will be not, because this was a sample file, many different variable are here, but I will try to make you understand how to conduct t-test. And this is the in this example we will be talking about the independent sample t-test. So whenever the independent sample means you are talking about two different samples, both samples are, suppose one sample is boys and other sample is girl, and suppose one sample is from urban setup, one sample is from rural setup, and you are trying to compare them on a particular dependent variable, suppose lifespan, suppose achievement score, suppose uh, interest score. So you try to see that if there is difference between the both independent groups on a particular dependent variable. So here we will try to see that here in this particular example, you can see that I will try to see that there is one variable definition. You can see in number 5, you can see that athletes, this particular athlete is there. So this particular variable definition talks about the if a person is an athlete or non-athlete. So basically, it has been uh, categorized with uh, 1 being the athlete category and 0 being the non-athlete category. So in this way, you have defined this one. So you can 1 or 0, it is like that. Means 1 is for determining if it is he is a athlete, and 0 is non-athlete. So in this particular variable definition of athlete, it is basically denoting that 0 is for non-athletes and 1 is for athlete. Like that, you can do in the other way also, means making 0 as athlete and 1 as non-athlete. But here in this particular variable definition, it has been defined as athletes are entered as one coding, and then non-athletes are being coded as 0. And then we will try to see, so this is the categorical definition, just like what I was talking about boys and girls. Similarly, here it is athlete and non-athlete. And the other variable on which, the dependent variable that on which you want to compare is mile minimum duration, means how much time it takes to cover 1 mile by this two category of people. Means if they are trying to cover a particular distance of 1 mile, how much duration they are taking. So basically it depends upon, it seems that it depends upon if a person is athlete or non-athlete. So here we will try to compare this particular two this particular two categories of athlete and non-athlete on the basis of how much times they are taking to how much time. So basically, it is trying to see that how much time it is taking to compete the particular, means what is the difference if there is a significant difference between the athlete and non-athlete category in terms of how much time they are taking to cover 1 mile. So let us try to see. So before performing the t-test, we will first try to see the nature. If it means preliminary investigation we can do, and we just try to explore that if which type of outcomes we are getting. So there is always the chance of uh, going for some. So there is always a chance. So there is always a chance of going for exploring the characteristics of these variables. So if you can see there is in analyze one, you can go for descriptive statistics, and you can go then there for explore, and then you can always choose this dependent list. Here in the dependent list, you have to see the mile duration, and in the factor list we have put the category variable of that particular variable, and if he is athlete or non-athlete. Now if you click on the OK command, you can see some statistics is there related to that particular outcome. Means as I told you, 0 is the non-athlete category and 1 is athlete category. So you can see here 226 non-athletes are there, and one for one which is athlete category. Here 166 athlete category people are there. Now if you see this, I am avoiding this. This is not required just because we are going for the initial inspection. You can see this is the box plot of these two categories. So 0 is for non-athlete and 1 is for athlete category. And you can see that uh, mile duration to cover a mile is for the 0 category, which is for the non-athlete group. You can see that it is quite higher. The duration is quite higher. The this is the median value, and you can see that it is around uh, 8 or 9. It is like this. This is the average part for the mile duration, and even the maximum is more than 10 also. And here for the athlete category, you can see that it is quite lower because of course the athlete can cover a distance in lesser time duration. So you can see that differences are quite visible. Also, one thing that you can explore here is that the uh, spread of the data. You can see that the spread, the variance of this particular set of non-athletes, it is quite higher than in comparison to the spread of data in the athlete category. So that is also one of the concern, because you have just seen that you, for conducting a test, the variance among the groups should be similar, and if it is non-similar, then which type of alternatives you can do. Means you can conduct t-test, but you have to take care of the variance also. So that we will try to see how you can interpret the result when the variance is of different type, if the spread is not similar in both the groups. Okay, so let us go to that particular data again. Now we will go for independent sample t-test. So for conducting this independent sample t-test, again you will go for the analyze button, and then you can click in the compare means category, and then you have got this independent sample t-test, which I told you that I will be explaining. So you go for the independent sample t-test, and then if you open this one, you can see here that this is the list of variable which is available in this particular set of data. And this, then you can always take this mile duration to the test variable, because that is the dependent variable that you want to see that if difference is there or not. Or you can say that this is the continuous variable for which you are trying to see the differences. So you will take this mile duration to the test variables, And for the grouping variable, this is the categorical groups for which we are going to test that the difference is there or not. So athlete, because for athlete and non-athlete you are going to do, so you will take this athlete category in the grouping variable. Now, once you have taken this here, you can see that this defining the group is required here. So for defining groups, you can see here. So if you see here, you have got the grouping variables. So here, once you have put this grouping variable here, you can see that question mark is visible here. So if you see this, you can always have to define the group. So you have to, as for group one, it is already seen that it should be 0 here because you have defined it as 0 and 1. So you write 0, and for group 2, you have to put 1 here. By default, it was showing 1 and 2, but you have to define it as 0 and 1 because in that way only you have defined. If you have defined it, taken this variable in the string category, and you have written like using the text athlete and non-athlete or A and N, then you should have written A and N here. Means the way we need which you have coded that one, that only you have to write here. Now cut point is not required here. Cut point is basically when your categorical variable is also in a continuous scale in decimals or point, then you can write cut point. So it is not required because the whole numbers we have used, and basically it is not the case where we have to use these cut points. So you have to press in the continue button, and then let us see what are now this estimate effect size. You must be knowing about effect size. So effect size tools as the difference. First you have to find out the statistical significance of the t-test, and if it is significant, if it's significant it comes, then every time you have concern more about if the difference is effective or how much effective it is. So earlier version of SPSS was not giving this particular effect size estimation um, facility, but now SPSS 27 and above has included this estimate effect size uh, calculation. So you can always uh, check this one so that you can see the effect size. If you are clear about, because we have seen the with earlier investigation, we have seen that with that box plot categorization, we have seen that differences are there. So it is better that you go for estimating the effect size. Now let us see what is available in the option category. Option, nothing you have to change. Every 95.05 level only you are going to estimate. So it is confidence interval is 95%. That is quite okay. And then so bootstrap also is not required. So after selecting all these things, you can always go for clicking on this okay, and then you come up with this result. This is the result. You have seen this box plot earlier. Now this result you have obtained by running this t-test. Now there you get three different tables. So basically you have to find out, or whenever you are reporting this table to your research report, you can decide on which format you have to include our table, which type of um, inputs you want to provide in your report. Means it is not required that you put all the three tables there, but it depends upon the research report format in which you have to report and submit to your institution or an educational body. So that you decide, or your institution will decide that which entries you have to report. But it is quite sure that you have to report the t values. That is quite sure. Level of significance also you have to report. So, but let us first understand this particular table. So first table here, it talks about, it gives the descriptive of both the groups, athlete and non-athlete groups. So 0 is non-athlete and 1 is for athlete. And then you have got number of people there, and then duration to cover this particular mile is mentioned here. So 9 minutes, and this is 6 minute 51, like this it is there. So like this you can see here, and then you can always see the so you can so this is about the first table of outcome, means you have seen the mean and then the standard deviation is there. You can always see again that what was visible in the this one the box plot. You can see that the for the non-athlete category the standard deviation is much higher than in comparison to the standard deviation for the athlete category. So now you come for the second table. Here you are conducting before conducting the t-test or interpret the t-test result. This is a very nice feature available in t-test this SPSS t-test, that you can conduct Leibniz test for equality of variance. So this here you can just see this. Always try to see that if the variance is equal in both the groups, that means what I was talking about, what we have seen in the figure, box plot figure. This is the statistical test. There you have seen in the graph, but this is the statistical test to see if the outcome means variance in both the groups are same or not. So here the statistical hypothesis or null hypothesis is that both the groups variance is equal. So that is the assumed hypothesis. And then you conduct Leibniz test, and then you just see that Leibniz, just try to see. This is what you are getting here. This is you are getting here. This equal variance is assumed. So here, this is the assumed hypothesis, and then the test result what you have got here is 102.975, and then if you see the level of significance P, then you can see that it is coming less than 0.001. This it means it is highly significant. That means you have to uh, you fail to accept this null hypothesis, and then uh, you have to go for this is the accepted hypothesis, equal variance not assumed. So this test tells you that if the groups, athlete and non-athlete groups, have the same variance. So as it was visible in the box plot also, and as you have seen here also, that this is not satisfying. So you can always see that both the group variances, both the uh, group standard deviation is not equal. So after seeing this result, when you go for the next column for t-test, you just try to see that two values are there, 13.475 and 15.047. Now, this particular result of Leibniz test tells you that among these two values, which one you have to report. Because this particular equal variance assumed condition is not met here, you have to report this second result of t-test, 15.047. This one only you have to report. So this is your calculated t value, and then you just try to see the difference here also. First it was degrees of freedom for independent sample t-test is n minus 2. Entire n means both the groups add up and then subtract 2. So this is when the both the group variance is same, then only you can n minus 2 formula you can use. Otherwise the alternative uh, uh, degrees of freedom formula is there, and by using this one you have seen that the effective df has reduced. It has become 315.846. So this is the reported 315. Now why it is happening? Because the group variance are not same. So that's why all the sample points cannot be taken as considered for uh, checking the degrees of checking the t-test result. So effective df is 350. So otherwise, if it is not like that, if this Leibniz test is not significant, then you can always report the first value and then the first degrees of freedom, whatever is there. So here now you see the p value here for the t test. This is for the t test. This is for t test. This is the value. So here also you can see both. This is less than 0.001. So you can say that this result is quite significant, because whenever it is less than 0.05, you can say the result is significant. So you can see, and then other columns are there. You need not have to report that one. So you can always say that this value is significant, and we can see that always you can say that the there is a significant difference in the time duration, minimum time duration of the athlete and non-athlete categories while they cover a particular distance. So this is how we are interpreting the result. Suppose you have framed the null hypothesis that there is no difference between the both the groups, athlete and non-athlete, in their time in completion of a mile distance. Then that hypothesis has to be rejected here, because the result has become significant, has become less than 0.05. So after getting this, interpreting this particular table, now we move to the third table. So third table gives you the sample effect size. Now Cohen's d is the most popular one, by which you can say that what is the uh, effect size. So you can see that point estimate. So if it is around zero point 0.8 or more, then it is called as quietly significant. The effect size is quietly significant. And then you can see here the point estimator is giving you 1.377. So it is talking about that the effect size is quite significant or quite higher. You can always say it is not moderate, it is quite higher, because it is uh, much more than what is the what you can say significant size of effect. It actually it gives you the, in terms of what you can say deviation units in the normal probability curve. So you can see that the deviation on the normal probability curve is in terms of 1.377 units. So it is quite higher than what is the required benchmark of uh, categorizing it in the higher category, not in the moderate category. It is zero point 0.8 and above. So you can always say that this effect size is higher. So this is about a particular sample test which you can use a sample, whatever sample file was there, that using that one I explained you how to conduct an independent sample t-test. So now we will try to see one more example of independent t-test, taking example from the field of social science or education, so that that area, or which area we are concerned about, the students from the background of education can understand. So you see, this is one sample file which I have created. So here you can see the variables are gender, achievement, interest, and location. So just try to recall that how you used to enter variable names. You can watch my previous videos on also how to enter data in SPSS. There also you can understand all these fields. So for clear description of this variable definition, you can always refer to that particular video. But let me recall this one in a brief. So this you can see that these four variables are there. These suppose one study is there where you want to see that if there is difference between the male and female students in their achievement scores in science or interest towards science. So gender I have intentionally taken as a string so that you can understand how, if it is entered in a string category, how the outcome will come. And then achievement is taken as a numeric, because continuous scale is there and numeric variable is there. Interest, you can see that in the variable definition you cannot give gap. So you can write interest in science, you can always write here. And then you cannot, if you provide gap, then this there will be syntax error, but you can always label it here in the specific sense. I have written here interest in science subject, and it is also numeric, and the scale is the ratio scale. You can always see. And the location also one categorical variable I have taken, where location has been taken in numeric scale, so that you can differentiate. If it is string, then how the outcome will come, and if it is numeric, then how the nominal definition, nominal values will be displayed, that you can understand. So here also I have labeled, I have given the values as 1 and 2. You can see here, uh, always you can see how the values have been defined here. 1 is for urban and 2 is for, you can see here, 1 is for urban and 2 is for rural. So in this way, I have defined this variable, and then you can see the data view. So here you can see the gender has been taken as male and female. So you can see all male, female, these all categorizations are there. And then you can always see the achievement test score. Then if you want, you can always remove the decimal also, because in the variable definition, decimal place is also there. You can always, if you want, you can remove this, and you can see in the data view. Now achievement test, only the whole numbers is there, and then interest in science, and then location in terms of 1 and 2. If you want to see this location in terms of its values, you can always click to this command. You can see it has been now the terms of values, and if you want to see in the numerical coded form, then you can always write like this. So this is about the data which, on which I am going to run the independent sample details. Suppose your null hypothesis is that there is no difference on the basis of gender in the achievement of uh, the students, and always there can be one other hypothesis also, that there is no difference in the interest score in science of the students on the basis of gender, and is similarly for the location also, that there is no location wise differences in the achievement. If a student belongs, is residing in an urban area, his achievement test score will be higher or lower. It is indifferent, or you can say that there is no difference on the basis of where they are staying and how they are performing in science, and similarly in the interest in science test. So you have to run the statistics on this one. Here also you can always explore the data first before running the t-test. So I will go for descriptive statistics, and I will run explore here. I will take the uh, dependent list of achievement and interest, and you can see the gender list. You can put here location also, you can put, and then you try to see what is the nature of data coming here. So here the distribution of the scores are there. For male female it is there, and then you can see here, this is the, and you cannot identify the exact difference, because box plots are looking something similar, little bit differences is there, but still you cannot say that the difference is significant or not. So this you can see for the gender category, you can see this type of differences in achievement. And then if you see the interest in terms of gender, you can see that for the interest, the variance of this particular group for the female category, the interest in science is spreaded, the variance is little bit more than in comparison to male, but still you have got Leibniz test to test this one. And similarly for the location also, you can see that the spread is quite similar in both urban and rural category. And then you see there's this interest in science. Similarly here, the standard deviation is quite in the higher side. So this where in the first example you can easily say that this difference were significant by seeing the box plot. Here you can only say about the something about the variance, but not about the differences. Now we will try to test the particular thing in terms of calculating the t-test value. So you again go for the analyze command, go for the compare mean command, and then you can click in the independent sample t-test. And what you can see here, I can put more than one test variable also. So
because both this what you can say, both these variable dependent variables has to be tested. So I will put both the variables here, and then one at a time, because gender, you cannot put two variables, grouping variable here. So I will put first gender here, and then you have to define the group. So here you have to define it, because I have named it, it is in a string. So I have to write it here male, and for this group 2 I have to write it here female. Then I will press continue. Other things, the estimate effect side is already there. Grouping variable I have done, options also it is quite okay. So I will press on the OK command. Now see, this is the result that you have got. So you can see for you can see the first table. It is about the descriptive statistics of this distribution. The male is 127.6 and females are 129. The mean is here. It is looking little bit same for the achievement and interest also. The it is about the same. And then their standard deviation is also written here. Now, if you see the Lebanese test for equal variances assumed, you can see that for achievement, the F value is 0.609, and for this, you can see always this uh, P value here, P value is 0.436, which says that it is not significant. It is not significant. Similarly, for this particular P value, you can see that it is 0.194. So for achievement, it is not significant. For interest category, also the value is not significant. So what we can see that we can say that this uh, particular uh, equal variances assumed is holds for both interest and for achievement. So you have to report the top value of T, which is minus 0.3067 for achievement. And similarly, for this, you can always say that it is 0.429 for interest in science. It is quite lower in comparison to achievement. The difference is quite lower in terms in interest to score. So minus sign, as you already know, this is not to be considered, because the differences only you have to see. So you have to report T as T. You have to report as T. You have to report as T. You have to report as uh, point 3.067. So in this way, you have to report 3.067, because negative value is not. It is just only says the direction of the differences that you have calculated. Maybe the female mean is more than the male mean. That's why the minus sign has come. Or similarly, in the case of interest. Now, if you see the t value is 3.067, and then you have to report this DF only here, also this DF only, because this category is correct here. This hypothesis, framed hypothesis is accepted. So this all things that you have to report. Now, level of significance, if you can see, this is 0.002. So if it is less than 0.05, then it is significant. So you can say that for achievement, the difference is significant. But for the interest, you see the value is 0.668, which is not less than 0.05. So this is not significant. This is not significant. This is not significant. Now coming to the effect size, you can see that the difference is 0.384. It is quite moderate in size, very small, mild effect size is there for achievement scores. And because in interest you have already seen that difference is not significant, you can see that point estimate is in 0.05, much lesser. Please, as we have already seen, the difference is not significant, and so you are not going to consider or see the interest in size, science subject, this effect size. Only have to consider for achievement effect size, and which is quite mild effect size is there. So in this way we can interpret the result. So this, you can also run this one uh, for what you can say, for this location wise. You can always see. So if you go for the compare means, and then you can go for independent sample t-test. Here you will just put the location here, and again you define it, because it has been taken as 1 and 2 only. So I will keep it like this, then I will press continue, and then I will press OK here. So you just see, this is the outcome for urban and rural. Here you can again see for the first category. For the first category, you can always see that for the first category, the F is not significant. It is not significant, but for, because you see this is 0.611. But for the interest in science, this is significant. This is significant. So for reporting the t-value, you have to, for the achievement on the basis of location, you have to report this point at 2.750. But for the interest in science subject, you have to report this 0.298. Almost it is same only, but still, if you try to see, this is the p-value. You can see that level of significance is also just nearing to 0.05. So that's why it is quite similar. So now if you see the level of significance for the t values. So if you see the p here, it is 0.006. This is less than 0.05. So this value is significant. And for this, you can see the value is 0.766. It was 0.006. Here it is 0.766. So it is, this t value is not significant. So you can see that in the achievements test, on the basis of location, there is significant difference, but on the basis of the interest in science subject, you can say that the difference is not significant. Now, if you see again, if to report the effect size for the achievement only, we'll try to see that what is the effect size. So you can see that the effect size, again, it is quite mild, quite small, 0.344, but because it is zero point 0.8 or more, then it is quite strong, but it is mild here. But interest, for the interest, you just see that this effect size is, or point estimate is much lower. At least you can see that the result is not significant, so we need not have to consider this one. You have to just see for the achievement test. So this is all about the independent sample t-test. So if you have to conduct independent sample t-test, how we'll be running it on the SPSS that you have understood here. So I hope you must have understood this one. Try to uh, watch this video with patience, and whatever workout processes which I have told that you try to follow and practice, you will be able to do t-test. So in the next video, we will be talking about other type of t-test. So please subscribe to this channel. Thank you.